Good afternoon, students. Today, I'll start with physical properties of metals and non-metals. You people already had this chapter in your 8th standard. So, physical properties and even some of the chemical properties you are well versed with. So, hardly very few topics are new which you are going to study this year. For example, formation of ionic compounds when metals react with non-metals. Actually, ionic compounds are formed. That will be something new which you're going to study. Otherwise, most of the physical and chemical properties you have been taught in your 8th standard. Still, I am going to repeat with exceptions also in the physical properties of metals and non-metals in more detail. So here we go with the topic, and I'm just explaining with a animated video so that you remember and it fixes in your mind. Today we'll learn about the physical properties of metals and non-metals. To start with the physical properties of metals, the first property is that all metals exist as solids at room temperature. Example, you have seen iron, lead, zinc, copper, all this exist as solids except mercury as a liquid. Metals are good conductors of heat. Silver and copper are the best conductors of heat. Lead and mercury are comparatively poor conductors of heat. Metals are good conductors of electricity also. Thus, they find application in insulated wires. Copper wires and aluminium wires are seen inside the insulated wires used for electrical appliances. Metals are malleable. So you've already understood what you already have studied about malleability. It is the ability of the metals to be beaten into sheets. In your 8th standard, you have learned these properties of metals. So you can see gold and silver can be beaten into thin sheets. Metals are ductile also. What does it mean? Ductility is the property of the metal to be drawn into thin wires. Gold can be 1 gram of gold can be drawn into 2-kilometer wire. Metals are generally hard. Example, copper, iron, aluminium. Exception are alkali metals like sodium, potassium, etc. They can be cut using knife. They are that soft. They are also called as soft metals. Metals in their pure state have a shining surface. This property of metals is called metallic luster. You have seen gold bangles, silver bangles, aluminium utensils, copper utensils. They have shine, that is, they are lustrous. Metals, on hitting on a hard surface, give a ringing sound, which shows that metals are sonorous. Example, your school bell is made up of metal. It gives a ringing sound. Metals have high melting point and boiling point. Example, iron has a melting point of 2750 degrees Celsius. Metals also have high density. Density, you have learned, it is mass per unit volume. Iron has a density of 7.874 grams per cm cube. Exceptions are sodium and potassium, which have very less density. Coming to the physical properties of non-metals, they are just the opposite of metals. Non-metals are either found in solids or gaseous state except one, that is bromine, which is a liquid. An example of non-metal usually are poor conductors of heat and electricity. For example, you take coal in a tester, you can make out that it's a poor conductor. But an exception is that graphite, which is also an allotrope of carbon, is a good conductor of electricity. Coal when hammered becomes powder. That means non-metals are brittle. Usually they are non-malleable, they are non-ductile. So non-metals are brittle, non-malleable, non-ductile. That is, they cannot be beaten into sheets, neither they can be drawn into wires. Non-metals are generally softer. For example, sulfur powder. Exception is diamond. Diamond being an allotrope of carbon made up of carbon is the strongest non-metal. Non-metals are non-lustrous. They do not have luster. They are dull. An exception is iodine. Sulfur, you can see, it is non-lustrous, but iodine has metallic luster. Non-metals are non-sonorous, that is, they do not make ringing sound when they are thrown down. So non-metals are non-sonorous. Iodine is an exception also. Non-metals have low melting and boiling point. Melting point of sulfur is 115.21 degrees Celsius and boiling point is 444.6 degrees Celsius. An exception is diamond with a high melting point. Non-metals have low densities compared to that of metals. Sulfur has as an example has a density of 2 grams per cm cube, very less as compared to metals. So hence we can differentiate between the physical properties of metals and non-metals this way. Metals have high density, sonorous, solids at room temperature, malleable and ductile. Metals have high melting point and boiling point, good conductor of heat and electricity, lustrous, etc. Whereas non-metals have low density, non-sonorous, may be solid, liquid or gas, neither malleable nor ductile, low melting point and boiling points, bad conductors of heat and electricity, and non-lustrous. With the exceptions, of course. So only knowing the physical properties of metals and non-metals we will not be able to completely differentiate between a metallic substance and a non-metallic substance. In order to be very much firm or clearly differentiate between a metal and a non-metal, we need to know the chemical properties also. So in the next session, we will learn about the chemical properties of metals and non-metals. Till then, take care. Thank you. Have a nice day.